You're looking at a wall. Light bounces off it, hits your eye. You see the wall. Simple, obvious. Except here's what should bother you. That light didn't come straight from the wall to your eye. It couldn't have. Let me show you why. Take a flashlight. Shine it at a mirror. The light bounces off at an angle. You learned this in school. Angle of incidence equals angle of reflection. The light comes in, hits the mirror, bounces off, like a ball bouncing off a floor. That's the picture everyone has. But that picture is wrong, completely wrong. And when you understand what's really happening, when you see what light actually does when it travels from one place to another, the whole world changes. Here's the experiment that breaks everything. Take a mirror, shine light at it. The light reflects. Fine. Now scratch away most of the mirror. Leave just a thin strip in the middle where the angle of incidence equals angle of reflection. What happens? The light still reflects perfectly. Makes sense. That's the important part, right? The part where the angles match. Now do the opposite. Scratch away only that middle strip. Leave everything else. What happens? The light still reflects. Not as bright, but it's there. How? You just remove the part where the angle of incidence equals angle of reflection. You remove the only part that's supposed to matter, and the light reflects anyway. Here's what's actually happening. Light doesn't bounce off one point on the mirror. It bounces off every point, the whole mirror. Every single point on that surface is participating. Even the edges, even the corners, even the parts where the angles are completely wrong. You don't believe me? I'll prove it. Take that mirror and very carefully scratch away parts of it in a specific pattern, not random scratches. A calculated pattern. Remove the parts where certain paths would interfere destructively. Keep the parts where paths interfere constructively. Suddenly the mirror reflects at impossible angles, angles that should never work. This is how a diffraction grating works. A mirror with most of it blocked off in just the right way. So the law you learned, angle in equals angle out, that's not really a law. It's an approximation. What's really happening is far stranger. Every possible path contributes. Light leaving the source goes to every point on the mirror. From every point on the mirror, it goes to your eye. All of these paths, every single one, they're all real. They're all happening. But here's the thing. For each path, we can calculate something called an amplitude. Think of it as a little arrow. The arrow's direction depends on how long that path takes. Light travels at a certain speed. Longer paths take more time, and time shows up as rotation of the arrow. Paths near the middle of the mirror where the angles match, they all take almost the same time, so their arrows point in almost the same direction. When you add them up, they reinforce. You get a big arrow. High probability. Paths near the edge of the mirror take very different times from their neighbors. Their arrows point every which way. When you add them up, they cancel. They spiral around and add up to almost nothing. And that's why angle in equals angle out. Not because that's the only path light takes, but because all the other paths cancel each other out through interference. Only the cluster near that special angle survives. The light is checking all possibilities. It's trying every path simultaneously, and the paths interfere with each other like waves. The ones that take similar times add up. The ones that take very different times cancel out. Now here's where it gets beautiful. This is true for everything, not just mirrors. When light goes from one place to another, it explores every possible path. Straight lines, curved lines, zigzags, loops, all of them. Why does light go straight in empty space? Because that's the shortest path, and at constant speed, shortest path means shortest time. Paths that curve away take longer. Their arrows rotate more. They point in different directions and cancel out. Only the straight path and its immediate neighbors survive the cancellation. Why does light bend when entering water? Because light slows down in water. The path that minimizes total time is not a straight line anymore. It's a path that spends more distance in air, where light is fast, and less distance in water, where light is slow. That's refraction. The light is finding the quickest route. But here's the thing. The light doesn't know in advance which path is fastest. It doesn't calculate. It doesn't think. It simply takes all paths, and the paths interfere. The mathematics of that interference automatically picks out the path of minimum time. This is completely insane when you think about it. A photon leaving a light bulb somehow knows about the glass in a window 3 feet away. It knows to bend at just the right angle before it gets there. How? Because it's not a particle following one path. It's a quantum object exploring all paths. The paths far from the minimum time path cancel through interference before the photon ever reaches the window. Let me show you something else. You can see this with your own eyes. Find a bright point of light, a distant street light, a reflection off chrome. Hold 2 fingers in front of your eye. Look through the gap. Squeeze the fingers together slowly. Watch what happens to the light. When your fingers are far apart, the light looks normal, a point. As you bring them closer, the light starts to spread. It elongates perpendicular to the slit. Colors appear at the edges, fringes, bands of light and dark. What you're seeing is light not going in straight lines. You're seeing it spread out at an angle. You're seeing interference between different paths through that narrow slit. With a wide gap, many paths are available. They interfere and cancel except in the straight-ahead direction. With a narrow gap, there's only one path, nothing to interfere with. So the light spreads out. This is why you can't see atoms with visible light. The wavelength of visible light is about half a micrometer. An atom is about 1/10,000th of that. The light explores regions much larger than an atom. It can't pinpoint something smaller than its own wavelength. It's checking too large an area. Now think about what this means. When you look at that wall, light isn't bouncing off it like a ball. Every point on the wall is scattering light in every direction. Light from every point reaches your eye by exploring all possible paths. The paths interfere. Only certain combinations survive. Your eye detects the survivors. Your brain reconstructs an image from that information. The wall is not where your eyes say it is. Not exactly. The light took time to travel. During that time, the wall moved. Earth is rotating. Earth is orbiting the sun. The sun is moving through the galaxy. By the time the light reaches you, everything has shifted. What you see is where things were, not where they are. You're looking at the past. For nearby objects, the delay is tiny. Light travels a foot in about a nanosecond. But for distant objects, the delay matters. The sun you see is 8 minutes old. Stars are years old, centuries old. Distant galaxies are billions of years old. Some of those galaxies don't exist anymore. They've died, scattered, but their light is still traveling toward us. We see ghosts. Every photon that enters your eye left its source at some time in the past. It explored all possible paths through space. The paths interfered. Only certain combinations reached you. The photon was absorbed by a molecule in your retina. That triggered a chemical reaction. That sent a signal to your brain. And somehow, from all of this, you experience seeing. Light is not a wave. Light is not a particle. Light is something else, something quantum. We don't have a good word for it because nothing in everyday life behaves this way. When you're not looking, photons explore all paths. They interfere with themselves. They spread out like waves. When you detect them, they arrive as particles, discrete clicks, whole photons, never pieces. Both pictures are real. Both are necessary. There's no contradiction, just 2 aspects of the same quantum reality. The ancient Greeks knew light travels. They didn't know how fast. Galileo tried to measure it with lanterns on hilltops. Too slow. Light is fast. In the 1670s, a Danish astronomer named Rømer figured it out by watching Jupiter's moons. They appeared at different times, depending on Earth's position. The delay told him light's speed, about 186,000 miles per second. Nothing goes faster. It's not just that we haven't found anything faster. The structure of space-time itself forbids it. Light speed is the maximum speed of cause and effect, the speed at which information can propagate. The universe has a speed limit, and light travels at that limit. So when light goes from here to there, it doesn't go instantly. It takes time. During that time, it's exploring paths, interfering with itself, finding the root of minimum time. All of this happens faster than anything else in the universe can happen, but it still takes time. And here's the deepest thing. Light doesn't need a medium. Sound needs air. Water waves need water. But light travels through empty space, through vacuum, through nothing. Maxwell's equations predicted this in the 1860s. Electricity and magnetism are connected. A changing electric field creates a magnetic field. A changing magnetic field creates an electric field. They can sustain each other. a self-propagating oscillation that travels through space at exactly the measured speed of light. Light is electricity and magnetism dancing together. That's what it is, an electromagnetic wave. And it doesn't need anything to wave through. Space itself is enough. So when you look at that wall, light didn't simply bounce off it and come to your eye in a straight line. It left the source, traveled through space as oscillating fields, encountered every point on the wall, scattered in all directions, explored all possible paths to your eye, interfered with itself, and the surviving paths created the image you see. All of this happened in billionths of a second, and it's happening right now, constantly, everywhere. Light is checking all the paths, always. That's what light does when it travels, something strange, something beautiful, something that reveals the quantum nature of reality itself.